All right, well, we're covering pairs of lines and angles, and mostly it's going to be dealing with parallel lines uh, and the special angles formed by parallel lines and a transversal, which we'll talk about here in a minute. So some special pairs of lines. First one, I'm going to write this one up here. You could just have two lines that are intersecting lines. Ignore that. If two lines are just intersecting lines, then that means they just intersect. They intersect at one point like we talked about earlier. Perpendicular lines are lines that look like this. They are intersecting lines, but they're special intersecting lines that intersect to form right angles. We've already talked about that one. Parallel lines, got to be real careful. You've had teachers in the past that have told you what parallel lines were, and I'm sure they just said lines that never intersect. That's not the case. They have to be coplanar lines. And coplanar lines are lines that are on the same plane. So they have to be on the same plane. So if we're looking at two lines on the same plane, I can't really, it's hard for me to draw anything up here that's not on the same plane because the whiteboard is a plane. So parallel lines might look something like that. The symbol for parallel is this. So if we wrote out something like line AB and line CD, and we wanted to say that they're parallel, we just put that parallel symbol in between them, and this is red. Line AB is parallel to line CD. Same as when we did perpendicular lines. If we wanted to say two lines were perpendicular, then we put that upside down T in between there, and that's how we would write it out. So that this one says line AB is perpendicular to line CD. Skew lines. It's hard for me to draw skew lines. I'm going to try to, let's see if I can. Skew lines are lines. I can't really draw it on this two-dimensional thing. Skew lines are two lines that are on two different planes, but are never going to intersect. So, let's see if let me erase some of this. If I drew a plane here, and I had another plane that was sort of down below it, if you can imagine that as being three-dimensional. If there's a line on this plane, and then another line on this plane, well, these two lines are never going to intersect, but they're not parallel lines. They're not parallel because they're not coplanar. They're not on the same plane. Maybe if I draw this, and we'll talk about this later on the slideshow here. If I have this box, and I'm looking at certain parts or certain edges of this box, this one and this one are going to be parallel to each other. This one and this one are going to be perpendicular to each other because they're going to form a right angle right there. If we look at this edge of the box and this edge of the box up here on the back, well, those two are never, if I extend these out, they're never going to touch each other. They're never going to intersect, but they're not considered parallel. So maybe that helps. Those are skew lines. Through a point not on the line, there's exactly one line parallel to the given line. So if I'm given this line, and we got to go back a ways, we've been naming lines with two letters like line AB with the line symbol above it. But remember back at the start of the year, we also named lines with one letter if there was a lowercase letter given out by one of the arrows of the line. So this line we would name with the word line, and then H. So two different ways to name lines. So you got to remember this one because this section uses a lot of just that one lowercase letter, one small letter. What this postulate says is if I take this point that's not on this line, there's only one line that goes through this point in our world that's going to end up being parallel to this given line. So no matter who draws it, if they make this line parallel to this line, it's always going to be the exact same line that everybody draws. So it's something like that. These are the symbols for parallel if we're in a picture. So if you're in a picture, you got these little either triangle looking things or just like arrows, or sometimes different books will use just extra arrows like that. So if we're writing it out in words, if we want to say line H is parallel to this blue line, let's put a letter out here, we'll say N. So line H is parallel to line N. We write it out that way. If we want to show it in the picture, then we use these symbols to show parallel. Same idea for perpendicular. Remember the upside down T, as soon as you see that, you should think of right angles, 90 degrees. In our world, if we take this point and this line, there's only one line in our world that goes through that point and it's going to intersect that line to form a right angle. So no matter who draws it, there's only one line that's going to come down through there. Every one of us could draw a line that's perpendicular to this line going through point A, and everybody's going to draw the same line. Line's a little crooked, that's what it'd be. So when we're looking at this, first thing I want to do here, the green lines, these are called your coplanar lines, and here in a few minutes we're going to call them our parallel lines. They don't have to be parallel for all this stuff that we're getting ready to go over to work. Some of it they do have to be parallel, but for the special pairs of angles, you can still have the special pairs of angles even if the lines aren't parallel. We just don't have rules about what's true about those special pairs of angles. So if we're looking at this, the two green lines, the two coplanar lines, that would be line A and line B. The other line that intersects both of those two coplanar lines is called the transversal. That's very, 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 very important that you know that that's called the transversal. And that would be line D. So line D here is the transversal. If we have that, 8 angles are formed every single time. 8 angles are formed. And if, of those 8 angles, there's special pairs of angles. Some of them we already know, like we know angle 1 and angle 3 are vertical angles, so they have to be congruent. We know angle 5 and angle 8 are vertical angles, so they have to be congruent. And there's other vertical angles in the picture. We also know that something like angle 6 and angle 8 are a linear pair, so they have to add up to 180. They have to be supplementary. Angle 4 and angle 3 are a linear pair, and there's a whole bunch more of linear pairs in there. When we draw a picture, it looks like this. So you got your two coplanar lines, and then you got that one line that intersects them both, which is called the transversal. On this picture, these angles that are inside the two coplanar lines are called interior angles. Again, math people, very, very creative. They're interior angles because they're on the inside. The angles on the outside, 1 and 2, 7 and 8, are called exterior angles. Because they're on the outside. So you have the inside, you have the outside. Interior angles, exterior angles. Make sure on your pictures, make sure there's like 4 or 5 pictures where I got the wrong number right here. Change it to a 4. It's supposed to be a 4 on all of them. I think I left it as a 1. Corresponding angles. Corresponding angles are formed, there's a special pair, these are all special pairs of angles. The next 4 things that we're going to talk about. Corresponding angles are formed when you take the 2 coplanar lines or parallel lines, whichever ones we're dealing with, and the easiest way to explain it is if you smash them together. So if I take line A and I smash it down so that it lays right on top of line B, not fold it over to match it up, but just smash it, the angles that lay on top of each other are going to be corresponding angles. So if I smash this down, angle 1 right here, if I smash this top one down to lay on top of that bottom one, and this is easier if I'm showing you in real life instead of on a video. If I smash it down, angle 1 is going to lay on top of angle 5. So angle 1 and angle 5 are corresponding angles. And then hopefully you can pick out the rest of them there. If 1 goes with 5, 2 goes with 6, angle 2 goes with angle 6, angle 3 goes with angle 8, and angle 4 goes with angle 7. Now if I erase this, something that might help you pick out corresponding angles, those special pairs of angles, just they're special pairs of angles just like vertical angles, supplementary angles, so on and so on. Something that might help you pick that out. If I trace angle 3 and angle 8, let's say, that's a pair of corresponding angles. So if I trace angle 3 is right there, and then I trace angle 8, angle 8's right there. You can see that together they sort of form an F. So you might write that down there with corresponding angles. They form an F. That might help you pick them out as you're trying to figure out if, what special pairs of angles they are. So corresponding angles, smash the 2 lines together, and they're the ones that lay on top of each other. Alternate interior angles. First of all, interior tells us we're on the inside, so that means we're dealing with 4, 3, 6, and 5. Alternate means sort of alternate sides, or they alternate, however you want to think about it. It sort of means opposite corners. So we're looking at ones out of 4, 3, 5, and 6. Which ones are on opposite corners? Well, 4 and 6 are. So these 2 are alternate interior angles. And then 3 and 5 are. These 2 are alternate interior angles. See how they go sort of opposite corners. They alternate the sides that are on there. This one here is probably the most used one. So it's the most important of all these special pairs of angles that we're going to talk about today. And on this one, this is going to be really, really helpful. If you trace 3 and, let's say angle 3 and angle 5. If I trace angle 3, and I trace angle 5, you should see you get like a Z, or maybe it might be an N if it's turned the other way, or it might, if it's really spread out or something, it might look more like a lightning bolt. but usually I'll say a Z. So anytime you trace two angles and you get that Z looking thing, those are alternate interior angles. Alternate exterior angles, same idea. You can probably guess which ones are alternate exterior angles now. Alternate exterior angles got to be the ones on the outside. So it's got to be either angle 1, angle 2, angle 8, angle 7. Those are the exterior angles. Alternate exterior angles are going to be angle 1 and angle 8, angle 2 and angle 7. Nothing special about them. I can't tell you that they form anything when you trace them or anything. You just have to remember. So alternate exterior angles. Consecutive interior angles or same side interior angles. So we're dealing with, again, just interior angles. So 4, 3, 5, and 6. We want consecutive or same side. What I call them is roommates. They're the ones that are roommates together. They're the only pair of angles, the only two pairs of angles in this picture that don't have walls in between. So if we're looking at this, the ones that are roommates with each other are 4 and 5, and 3 and 6, angle 3 and angle 6. Consecutive interior angles, they're sort of the oddballs, and we're going to talk about that more here in just a minute. So all of these special pairs of angles work when we have two coplanar lines and a transversal. Now, what we're going to deal with most of the time is we're going to have two coplanar lines, but those two coplanar lines are going to be parallel to each other and the transversal, and then that's going to make all these angles special pairs of angles, and there's certain things that have to occur every single time. You still have vertical angles, so if I'm looking at this, I still know angle 1 has to be congruent to angle 3 because they're vertical angles. I know angle 5 has to be congruent to angle 8 because they're vertical angles. I know angle 7 has to be congruent to angle 6 because they're vertical angles, so on, so on, so on. There's all those, well, there's only, I think I did all of them but one, so I'll do the last pair. Angle 2 has to be congruent to angle 4. All those are vertical angles. Supplementary angles, ones that make a linear pair together. I'm not going to name all these because there's a whole bunch of them. But angle 1 and angle 2 have to add up to 180. They're a linear pair. Angle 1 and angle 4 are a linear pair. Angle 5 and angle 6, oops, forgot my angle symbol, are a linear pair. Angle 7 and angle 8 are a linear pair. Angle 6 and angle 8 are a linear pair. So on, so on. All of these, remember, have to add up to 180. So we still know all of that about this picture before we start learning any of the new stuff. This is the most important thing today. 4 theorems. These only work if the lines are parallel. Give you a second to write this down. Notice each one of these starts off, and I've shortened these up so that we can use them as reasons in 2-column proofs and stuff, and you don't have to write quite so much. These only work if we start off knowing, if we're given the information that the two lines are parallel. So if lines are parallel, if lines are parallel, if lines are parallel, all the way down through here. So if we're looking at this, the first one, theorem 314. If I have two lines, and I'm going to draw these, and I'm not putting my arrows on it and everything else, and we know that they're parallel, and we have our transversal. Remember, corresponding angles are the angles that if we shove these two lines together, smash them together, corresponding angle is going to be the angles that lay on top of each other. So with corresponding angles, this angle is going to be congruent to that angle. And then we have a bunch of other angles. I'm just going to mark those two for this. Those are corresponding angles. There's other corresponding angles. They have to be congruent. So corresponding angles have to be congruent. When you have parallel lines and a transversal, any pairs of corresponding angles have to be congruent. If I draw the same picture, and we want alternate interior angles this time, alternate interior angles would be like this angle and this angle. Again, they have to be congruent. So this angle is going to be congruent to that angle. And then the other pair of alternate interior angles in this picture, this angle and this angle, would also have to be congruent. Next one, alternate exterior angles. If I draw the same picture, alternate exterior angles would be like this angle and this angle, outside and on opposite corners. And again, they have to be congruent. So this angle has to be congruent to that angle. All of this only works if the lines are parallel. And then the oddball of the bunch is this one. These are the roommates. Consecutive interior or same side interior angles. All of the rest of these said that the pairs of angles got to be congruent to each other. They got to be the same. These say that they have to be supplementary. So that means the two of them have to add up to be 180. So if I draw my picture again, the roommates would be like these two angles. So these two have to add up to be 180 degrees. They got to add together to be 180. They've got to be supplementary. So corresponding angles are congruent if the lines are parallel. Corresponding angles are congruent. If the lines are parallel, alternate interior angles are congruent. If the lines are parallel, alternate exterior angles are congruent. If the lines are parallel, consecutive interior angles got to add up to 180. Four main rules. So if I'm looking at this, we have this picture here. And we're going to go through and decide some of the stuff we know. We already know stuff about vertical angles and linear pairs. So I'm not even going to deal with the fact that 1 and 3 have to be congruent because they're vertical angles. Or 5 and 6 have to add up to be 180 because they're a linear pair. We already know all that stuff. If these two lines are parallel, which those little symbols there tell us that they are, then we know stuff like angle 1 has to be congruent to angle 5 because they are corresponding angles. Angle 2 has to be congruent to angle 6 because they are corresponding angles. Angle 4 has to be congruent to angle 7 because they are corresponding angles. Angle 3 has to be congruent to angle 8 because they're corresponding angles. Angle 4 has to be congruent to angle 6 because they are alternate interior angles. If I trace them, they form that Z. Angle 3 has to be congruent to angle 5 because they're alternate interior angles. Angle 1 has to be congruent to angle 8 because they're alternate exterior angles. And then same idea, angle 2 has to be congruent to angle 7 because they are alternate exterior angles. Then the supplementary angles, again, I'm not going to go through all the linear pairs and everything, but the supplementary angles, the roommate ones, angle 4 has to be supplementary to angle 5. And angle 3 has to be supplementary to angle 6. 3 and 6 are supplementary because they're both right here, they're roommates together. So them telling us that these two lines are parallel, we know all of this information. Plus, we still know all the stuff about vertical angles, like angle 1's congruent to angle 3, angle 2's congruent to angle 4, so on and so on. We know all that stuff also. So we know a whole bunch of information about this picture. Next theorem, we're going to draw this together in a plane. So this is telling you that everything's got to be all in one plane. If a line is perpendicular, remember that means it forms right angles. A line is perpendicular to one of two parallel lines, that symbol means parallel, then it has to be perpendicular to the other line. So if I have this, that's one of my lines. That line N, we'll call it. And then we have another line, that's line H. And we know that those two lines are parallel to each other. And we draw this transversal in there. And we'll call that transversal line T. And it forms a right angle with this line. Then what this theorem is saying, it must form a right angle with the other parallel line. So it has to form a right angle there also. So if it's perpendicular to one of these, it's got to be perpendicular to the other parallel line. But the lines have to be parallel. The two lines have to be parallel. It can't be just two random lines and say, okay, it's perpendicular to this one. Well, if these lines aren't parallel, then it's not going to be perpendicular to the other one. We want to find all these angles. And I know easiest thing to do, we know that this angle is 112, well then angle 5's got to be 112. They're vertical angles. Let's go some different routes here. If we're looking at this angle, the 112 one, if we smash these two lines together, angle 3 is going to lay on top of it. They're corresponding angles. They have to be congruent, so angle 3's got to be 112 degrees. Alternate exterior angles have to be congruent. So if this angle is 112, the alternate exterior angle with it is angle 1, so it has to be 112 degrees. Oops. And you'll notice here angle 1 and 3 come out to be congruent because they're vertical angles. Angle 3 and angle 6 are roommates, so they have to add up to 180. So 180 minus 112. If we borrow there, that's 68 degrees, so angle 6 has to be 68 degrees. Angle 3 and angle 5 are alternate interior angles. If I trace them, they form a Z. So they have to be congruent, alternate interior angles. So that has to be 112 degrees. Same thing for angle 6 and angle 4. They're alternate interior, so that has to be 68 degrees. And I don't care how you find all the angles, using vertical angles, supplementary angles, whatever it is. I'm just trying to show you these new rules so you can use them. So if you say, well, that's just too much work, I know 4 and 2 are the same, so I'm just going to write 68 in here. That's great, whatever. As long as you know how to find each angle. And down here we know 6 and 7 are vertical angles, so that has to be 68 degrees. Anytime you're given a picture that looks like this, and they give you one of the angles, you should be able to find all other 7 angles. Same picture. Write this in there, find x. We want to find x also. Well, if we're looking at this, several different things you could do. We know that this angle is 115 degrees. Well, then angle 7 is a vertical, so it's 115. So we'll write it in there. That is pretty easy. This angle and angle 4 are alternate interior angles. So angle 4 has to also be 115 degrees. This angle, the 115 and angle 2 are corresponding angles. If we smash the two lines together, they're going to lay on top of each other. So angle 2 has to be 115 degrees. This angle and angle 3 are roommates, so they have to add up to 180. So 180 minus 115, we borrow there. That gives us 65, so that angle 3 has to be 65 degrees. 3 and 5 are alternate interior angles, so it has to be 65 degrees. Angle 6 down here, vertical angle with angle 5, so let's just write it in, that's 65 degrees. This angle up here where this is, we're going to find x also. Well, we know that these two are vertical angles, so the easiest thing to set up is probably x plus 5 equals 65. Subtract 5 on both sides, and you end up with x equals 60. And we also know that this angle is 65 degrees. And I think we've found them all. Little tougher when you get to something like this. Because now you have your two parallel lines, and now instead of having just one transversal, you have two transversals. So line D is a transversal, and it looks like I didn't put a letter on the other one. We'll call it line E is also a transversal. What you have to do on this, no easy way around it, you have to separate stuff off. So if I separate off my two parallel lines, and it doesn't have to be some spectacular drawing, and then I use D as my transversal. So I have that picture. I got angle 1, angle 2, angle 3, angle 4. Angle 7 goes right here. Here's where you got to be careful. This is not angle 9 or angle 10. It's the two of them together. This is angle 8 over here. This is not angle 5 or angle 6. It's the two of them together. So we can't really mark them. We can find out what they are, but we can't really mark them. They tell us that angle 10 is 60 degrees, so I'm going to write that in there, 60 degrees. Angle 7 is 50 degrees. If I go over here to this picture, I know angle 7 is 50 degrees. And I can just find all the angles in this part of the picture. So this angle and angle 2 are corresponding angles, so angle 2 has to be 50. Angle 4 and this angle are alternate interior, so it has to be 50. Angle 3 and this angle have to add up to 180, so it's 130. Angle 1 then is 130. Angle 8 and this angle are vertical angles, so it has to be 50. This whole thing here has to be 130. This whole thing has to be 130. So if I come back down here, I know that angle 1 is 130. I can write that in right there. Angle 2 is 50. Angle 4 is 50. Angle 3 is 130. Now over here is where you got to be careful. We know angle 7 was 50. Well, angle 8 and angle 7 are vertical angles, so angle 8 has to be 50. But this whole angle is 130. We know this part's 60. Well, we just take 130 minus 60, which means angle 9 here has to be 70 degrees. Well, if we look at 9 and 6, they're vertical angles. So angle 6 has to be 70 degrees. And again, we know this whole angle is this whole angle, which is 130. So that means this angle has to be 60 degrees, and that should work out here because these are vertical angles. So we know all that information. Now what we do, we take the two parallel lines. Instead of using the red line as the transversal, we use the blue one. We got 11, angle 12, angle 14, angle 13. This is angle 5, so it's 60 degrees. This one over here is these two together, so that's 120 degrees, which those two should add up to 180. This has to be 120, this has to be 60. And now we can find 11, 12, 13, and 14. 13, these are alternate interior angles, so 13 has to be 60 degrees. 14, these two are alternate interior angles, so 14 has to be 60 or 120 degrees, sorry. These two, 11 and 60, are alternate exterior angles, so 11 has to be 60 degrees. And 12 in this angle, I'm just doing different things. There's all kinds of ways you could come up with it. 12 in this angle are corresponding angles, so they have to be the same. So it has to be 120 degrees. Now we've found every angle in that picture. A crook problem. We look at this. We know that these two lines are parallel. The bad thing is, what we would normally consider our transversal here is crooked. So it's not going to work. But we had a theorem that said if we have this point right here and we draw a line through that point, there's only one line in our world that's going to be parallel to these other two lines. So we can draw in that line because no matter who draws that line, they're going to draw the same line if all three of those lines are parallel. And now what we have is we have this line and this line together as two parallel lines, and we're going to use this as the transversal. And this angle is 29 degrees. Well, these two angles are alternate interior angles, so that has to be 29 degrees. So this top part right here, where we just drew in that line, has to be 29 degrees. And if we split off the bottom two, so this line and this line, and use this as the transversal, we know that this angle is 26 degrees. Well, again, this angle right here and that angle are alternate interior angles, so they have to be congruent. That means this has to be 26 degrees. And to find the measure of angle 1, all we got to do is put those two together. So 29 plus 26, and that comes out to be 55 degrees. So the measure of angle 1 has to be 55 degrees. Now some students ask, well, so all you're doing is adding those two together every time? It depends where they put it. If they told you this angle over here or something, then it's different. You gotta, it's gonna come out a little different. So you gotta really know your rules. We're going to do these examples together next time. Your assignment is this. It's on your notes there. Make sure you do it. The other part of your assignment. The other part of your assignment is there's a redo paper for the 2-column proofs for the test. And you redo those 2-column proofs. There's a worksheet. You redo those 2-column proofs, bring it back next class, and I will add points to your test, to your test grade. If you don't need points added to your test grade, that's fine. Don't do it. But I would highly suggest it.